Pluto's orbit crosses that of another planet. That's no kind of behavior for a planet. What if I told you that two of the most mysterious planets in our solar system just collided? What about the fallout? This was really unexpected. Famous astrophysicist Neil deGrasse Tyson has just revealed information regarding a cosmic event that may change our understanding of our galaxy. An intergalactic shock wave is focused on Pluto and Neptune, two seemingly faraway celestial worlds. But what does this portend for humanity's knowledge of the cosmos, space travel, and Earth itself? Hold on tight, because this tale is going to astound you. Pluto and Neptune's avoided collision. The fine art of orbital dance. The orbital resonance that keeps Pluto and Neptune from ever colliding is one of the most fascinating parts of their near collision. While their orbits would appear to collide in a disastrous manner, the delicate gravitational connection between the two planets keeps them at a safe distance. The cosmic wonder that is Pluto and Neptune is their natural synchrony, which has captivated scientists for millennia. As a result of their 3:2 orbital resonance, Pluto completes 2 solar orbits for every 3 that Neptune makes around the Sun. They are never in the same spot at the same time, despite the fact that their orbits bring them near because of this mathematical harmony. This resonant phenomenon exemplifies the incredible stability that the cosmos can maintain under the control of gravity. But what would happen if that equilibrium were upset? Is it possible that these planets could be pushed out of sync and onto a collision track by outside forces? This delicate balance could be disrupted by even little gravitational disturbances. According to recent observations, a huge asteroid or an undiscovered planet far out in the solar system are 2 examples of extrasolar objects that could affect Pluto and Neptune's orbits. Entering the Kuiper belt by such an object might cause complete disarray in the orbital system. Because of this, some researchers have begun to wonder if the near collision is an indication of a much larger and more terrifying object in the solar system's outer regions. Now we must ask, is the resonance between Neptune and Pluto really steady, or is it more delicate than we believe? From the masses of invisible dark matter to the gravitational pull of faraway stars, there are an infinite number of factors that impact planet orbits. Even a little change in the equilibrium might throw the entire solar system into disarray. If we want to know how the planets will interact in the future, we need to know what this resonance is. Disruption of this delicate balance might have far-reaching and unexpected consequences for worlds beyond Pluto and Neptune. Through the examination of these interactions, astronomers aim to discover more about the laws that control our solar system and the possible threats that exist beyond the planets that are now known to us. The powers that influence the circumference of planets. Cosmic shifts. As the near collision between Pluto and Neptune shows, the cosmos is always moving and impacting heavenly bodies by forces that humans can't even begin to fathom. Numerous invisible bodies tug at the orbits of celestial bodies like planets and moons, as well as faraway stars, disrupting the delicate cosmic equilibrium. However, how did these forces bring Neptune and Pluto so near to a catastrophic collision? Gravity, the universal law that controls the motion of all celestial bodies, is one of the driving factors. When we think about the enormous distances between objects in the outer solar system, the real intricacy of gravitational interactions becomes clear. Even though gravity is well understood when applied to stars and planets here, even tiny changes in gravity can have huge effects, maybe even changing the paths of whole planets. These cosmic occurrences might be influenced by more than just gravity. Dark matter and dark energy could also be at play. Pluto and Neptune, and all the visible stuff in the cosmos, are pulled inward by dark matter, which is thought to comprise the vast majority of the universe's mass. Even though dark matter is hard to see and detect, its influence on the motions of the stars allows us to deduce its existence. Investigating the factors that influence planetary orbits requires us to take surrounding stars into account as well. There are billions of stars in our galaxy, each with its own gravitational pull, so our solar system isn't out on its own. Planets like Pluto and Neptune are quite vulnerable to gravitational perturbations, which may cause disastrous events if a neighboring star were to come close to our solar system. Important concerns regarding the stability of the outer boundaries of our solar. The intricate relationship between Pluto and Neptune, locked in a 3:2 resonance, is a fascinating example of how gravitational forces maintain balance in our solar system. Despite their crossing orbits, they avoid collision because of this resonance, where for every 3 orbits Neptune completes, Pluto completes too. This delicate balance has held for billions of years. But what if something were to disturb it? The stability of this resonance is crucial. And if an external force like dark matter, another planet, such as the hypothesized Planet 9, or even a passing star interfered, it could throw the orbits into chaos. Even slight gravitational changes could destabilize the resonance, potentially leading to catastrophic collisions. This isn't just a hypothetical question for Pluto and Neptune. Resonances govern other planetary systems, moons, and asteroids, keeping the solar system in a relatively stable arrangement. Disrupting these resonances could have disastrous consequences, as planetary orbits could shift unpredictably. Pluto and Neptune's current situation might signal a weakening in their resonance, which could have far-reaching effects on the entire solar system. Researchers are closely monitoring their orbits, trying to learn more about what controls these unseen rhythms and how they might be interrupted. The cosmic dance between Pluto and Neptune also raises broader questions. Are similar resonances at play in other planetary systems? What happens when these patterns are disturbed? The origins of Pluto and Neptune's relationship lie in the early days of the solar system, billions of years ago. During this chaotic time, the planets were shifting positions due to gravitational interactions. Neptune, along with the other outer planets, migrated farther from the Sun, disrupting the orbits of smaller bodies like Pluto. As a result, Pluto and Neptune entered their current resonant orbit, avoiding collisions but staying closely linked. However, their recent near miss suggests this resonance might not be as stable as once thought. Could this be a lingering effect of the solar system's tumultuous formation, or something else entirely? One fascinating possibility is the influence of gravitational waves, ripples in space-time caused by massive objects moving. Since their direct discovery in 2015, gravitational waves have been linked to extreme events like black hole mergers. But could they also affect the orbits of planets within our solar system? Some researchers believe it's possible. While the gravitational waves we've detected so far come from distant cosmic events, smaller waves within the solar system could influence planetary orbits over time. Could Pluto and Neptune's near collision be a subtle sign of gravitational waves shifting their orbits? It's an intriguing theory that requires further study, but advances in technology may soon allow us to detect these minute and nuanced waves. This potential link to gravitational waves could open up new avenues in astrophysics, allowing us to understand more about how the most powerful forces in the universe interact with the planets and stars. But there could be even greater forces at play. Some scientists speculate that the solar system's location within the vast cosmic web, a structure of galaxies, dark matter, and intergalactic plasma, might also be influencing planetary orbits. As the solar system moves through this intricate network, tidal forces could subtly pull planets closer together or farther apart, potentially destabilizing resonances like the one between Pluto and Neptune. The upcoming close encounter between Pluto and Neptune might be a sign that these larger cosmic forces are at work. As we continue to map the universe's structure and chart the distribution of dark matter, we may uncover new insights into how the cosmic web interacts with planetary systems like our own. Looking forward, the big question is, what does the future hold for Pluto and Neptune? While their immediate collision threat has passed, their near miss has raised concerns about the long-term stability of their orbits. Could their resonance be degrading, setting the stage for more close encounters in the future? If this is the case, astronomers will need to keep a close watch on their movements to anticipate any potential dangers. A breakdown in resonance could signal broader instability in the solar system, with ripple effects reaching far beyond just these two distant worlds. Even the smallest shifts in planetary orbits can have significant impacts, affecting the stability of moons, the paths of comets, and other planetary dynamics. As we continue to study Pluto and Neptune's orbital dance, we may gain new insights into how resonances and gravitational forces shape the solar system, and how even tiny, invisible forces can have profound effects. The near collision between Pluto and Neptune has opened up new questions about the guiding forces in our solar system, including the roles of dark matter, gravitational waves, and the cosmic web. Our understanding of these phenomena is still in its infancy, but continued study promises to reveal the hidden mechanisms that control planetary dynamics. From this incident, one thing is clear: the solar system is a dynamic, ever-changing environment. While the orbits of planets may seem predictable, they are constantly influenced by forces we are only beginning to understand. As we peer deeper into the cosmos and explore these mysteries, we must remain alert and prepared for whatever comes next. What are your thoughts on the cosmic dance between Pluto and Neptune? Do you think we're on the verge of even more groundbreaking discoveries? Feel free to share your insights in the comments below.